Welcome to TutorASRumale, only knowledge, nothing else. Subscribe and click on the bell icon for updates on new videos. Like, comment and share it with your friends. Your comments and suggestions are most welcome. You see the mathematical typesetting in Latex. In last videos you already seen how to create the different folders and other things for the Latex, and there so we are creating here a new file to typeset our mathematics. Now I'm going to give the name to this file as math-mwe. So that is minimum working example for mathematics typesetting, and .tx is the extension given to this file. Anything that come after this percentage sign in Latex is considered as comment, so we are considering this as a comment. So we start with the begin document command. So we say document class first. We have to start with the document class. I'm giving here 12 point as the regular font size, and after this 12 point we are saying the class is an article class. Okay, now for the adding the packages so that we can do the mathematical typesetting, we require to use this command use package, and I'm using only the standard mathematical packages. AMS, which stands for American Mathematical Society, AMS Math. Then you are having AMS Sim. Then you are having AMS Fonts. So these are the three mathematical packages which are required for mathematical typesetting by default. And if you want the mathematical typesetting in straight times New Roman, you can use the math-typesetting. This package is actually used by Wikipedia people. math-typesetting. It's not necessary that you have to use the math-typesetting. It's okay if you not use the thing. So this is your document class use package. I'm adding now the title to this article. To this article we are saying math mode in is a reserved word in Latex, backslash, capital L, small a, capital T, small e, capital X, then backslash and space. Typeset the logo of Latex. So you see math mode in Latex, this thing, and the title, the author for the thing. So you are seeing the author here is TutorASRumale, that is me. You can add your name as a author. So now we are making begin document and end document. So as from our last tutorial, we know that whenever we add the title and author information, we must have to have here the make title command immediately after the begin document. And if you do not want to have the date, then you simply have to give the date either. So I'm not adding that date command here. Now let's start with the Latex thing. So we're seeing what is the Latex. Now Latex math mode have two type of math modes. Actually math mode have two types. Okay. These two types are first is inline math, and second is what we call displayed math. Okay. Let's see the example for this. Now how to use this displayed math. I'm adding a new paragraph to this Latex math mode. This have the two types, inline math and second is displayed math. So we are saying this first with the inline math. Inline math goes in line with the text. This is the simple meaning of the inline math. So inline math actually goes in line with the text. So example here, example, we are adding here now this $2 sign. What are the inline math? You have to sandwich that mathematical expression within the dollar sign. That must have to be start with dollar and end with dollar. So we are going to say here the a equals to, okay, we are saying sqrt, okay, and we are saying sqrt n, and some here we are saying delete and m. So this is a inline mathematics. Okay, this is an example of inline mathematics. Here the math expression is within the text. Okay, so it's within the text. Now we are having the mathematical expression which is displayed math. Whereas what you can say, whereas this displayed math as displayed math is stand out from the text. So we are having this text standard. So there are two methods of these. I'm giving this example. Now you see I'm writing here the example. I'm simply copying the expression that we are given, this expression. Okay, control C, and here we are adding with the control V, that is tested. Only I'm adding here extra dollar sign. So when we add $2 signs to sandwich the mathematical expression, it becomes displayed. Okay, so instead of adding it here, the math is in display mode. Okay, you will see the difference for this inline mode and mathematical mode. There is another way. To use display mode. Okay, so this another way is that instead of using the double dollar sign, you can use this backslash and then square bracket, and you are simply pasting the complete things here. I'm simply deleting this dollar because now we won't require the dollar signs when we are using this backslash and square bracket. Display mode, okay, where we are using what you can see here, we are using this and instead of double dollar. So we added this work command here, and likewise. So let's now save this file as a math MWE. So I'm saying save. So file is saved. We are saving here as a math-mwe.txt file, and we save this file. After saving, we are compiling this file. So if there is any error, it will show the error. There is no error. So there is no error, and here what we got. Now this is the output. We are in math mode in Latex. TutorASRumale. Today we created this. So Latex math mode, how these two types, inline mathematics and displayed mathematics. Now you see inline mathematics goes inline. So if you see this goes inline with the text, that A equals to NM. Here is inline. While if here is the displayed mathematics, you get this completely stand out. Now here math is in display mode. There is another way to use this display mode, and this is when you are using this, again it is get displayed. You are not using the double dollar signs. Okay, so this is a basic mathematical typesetting thing that you have to do in the Latex. Now we are going to see the different things when we are using the Latex documentation, or whenever you want to typeset the mathematics in Latex. There are different formulas. So from where this formula, how we will get this formula. So first formula that we are having this SQRT. So here are the, if you see this, here is what you can see the different formulas that you can use for the mathematics thing. Okay, you can use this, you can use these symbols, you can use these things, you can use this lambda, you can use this infinity and other symbols. You can go with those things. You even can add these different so you can say opening and closing brackets, right and left angles, triangles first. Okay, so after this you can even use with all these mathematical things from here. Okay, so these are the mathematical symbols that we can use. Let's typeset one simple equation for this. So here is an example. Is an example for this for this latex typesetting. So typesetting mathematics. Mathematics example, we are saying enter. Now if you see this, there's everything here, that whatever data written is within this begin and end document. So if you see this is within this begin and end document. Okay, nothing is after. So we are having this here is example for this. So we are going to use this display mode. Okay, so we are going to use the display mode, and in this display mode we are going to use something. So this stands for sum. Okay, now if I give this sum and what is underscore and in braces something, let's say suppose I equals to 0, and here power sign, that is shift 6, and here you can say I equals to 0, that is I equals to 0, and here we are saying I is LEQ. Okay. Less than or equal to stands for LEQ. I is less than or equal to, we are seeing some capital N. So this sum is given. So we say that is sum, and after this we are adding sum of some let's say f of xi. Okay, x, and we are adding suffix to it as I. So this is what we say. Save the file using this save, and say here is what you get, this sum I equals to I is less than or equal to f of xi. I want to make this one as an equation, complete equation. You can simply add before this sum, let's say some g of x is a function. Okay, g of x, we are saying g of xi is a function such that, so when you save this file and compile this using PDF LaTeX and see the PDF output, we will get this equation. Now you see, this is very easy to typeset such type of equation in LaTeX. While this, if you go with the other type of software, it is quite difficult to add the LaTeX things. Now what if I want to start, I can say to typeset something which is in terms of say array or like some logic. So there LaTeX gives the environment which called as array. So using array mathematics. So when we say environment, I have to add this array mathematics. So when I want to use the array for the mathematics, we have to use some package here, just above here in use package, and this package is use package array, because this package array is actually having the definition for the mathematical limits. And save this way, control S I type. So you have this array package. Now we are going to check how this array can be used to typeset something. So let's say suppose we have this us, we are going to typeset the array. So I'm saying this one thing and another. So here we are saying typesetting array, typesetting an array in LaTeX. So we are for matrix display. So we are actually displaying the matrix. For matrix display, we are typesetting this array. So the array start is here and array ends is there. So we have to use this begin array. So you have this package begin array and end array. Now when we say begin array and end array, we get this option. So we are having this left for left align column, C for center align column, and R for right align column. Okay, so we got this LCR. After getting this LCR column, so we have to add here this to add the thing like left braces, that is starting and opening braces. We have already seen this. starting and opening braces. So I'm seeing this is as a left. Okay, and here at the end I'm seeing as a right. So we already have this left, so we use this right. Okay, so I don't require to say, and I'm seeing adding some array element 12, 20, 13, 24. Okay, 34, 45. These are the random numbers I'm adding. 56, 45, 56 and 67. So we get this 3 by 3 matrix, but this is not yet complete. We have to add the column separator here. The column separator is given with the ampersand sign. So I'm seeing ampersand is added, ampersand sign is added here for the column separator. Okay, so this ampersand sign actually says that 12 is in first column while it separates 13 from the first column. So this is the start of second column, this is start of third column, but afterwards this is a start of fourth column. Now we won't require this in a fourth column 34, instead we require this in a first column, that is with this 12. So we have to show here the end of what you can say an array limit. So you have to add the new line character which shows the end of rows using this new line character, that is double backslash, and here you are also adding the new line character. Double backslash is added, your array is totally ready. We saved the program using Control S and compiling it using PDF Latex, and here is the array element typesetted. So you got this array element typesetted. You can make the changes here. For example, if I type this code completely, I'm copying this code here. Control C, and so just copy code, given some space so that the code will get, and instead of having this left bracket, we saying left and brace, and here right, and here we can add the right brace. Okay, and now if we compile this, it's showing some error. Sorry, and if we show add, it won't require left and right for that. So if you see this left and right, you got this. Okay, or you can go and use, instead of this we can go for this left L brace. Okay, and here you can use this command right L brace. So right, we won't require L brace here, R brace. So we are using this right R brace, and if you compile this, you will get an array which is now in left and right. Okay, so you will see this is an array, this is an array. So we can use these symbols or these commands from here to typeset the things. For example, you can add the inline character in inline math showing what you can see as an in $2 signs. You have to add everything. So we say here a simple equation for all, okay, for all x, okay, we say for all x there exists, okay, some y, okay, there exists some y, and then we have to add the such that command. Here you don't have the such that, simply have to check for the symbol. So you'll get the straight line here for the such that, or some mean such that x equals to y, but x, what we say, not equals to y. So here different symbols are there. You simply have to check whether the symbols are available or not. So here you are having these symbols, different symbols there. Okay. So where x is equals to y or x is not equal to y, and likewise. So we say x equals to y, x is not equal to y. All these symbols are here. We can have these symbols and likewise. So you say here we are saying, but x We'll just stick for the symbols here. Plus minus x not equal x is not equal to y. Okay, inline mathematics showing this, and we say this is save and compile, and we got this output that inline math showing for all x there exists y such that x is equal to y but x is not equal to y. So this is just simple thing. Now what happens generally when we go with typesetting all these mathematics, we require to use many times the equations and the equation numbers and likewise. So we'll see this next section here, or typesetting the equation. We say begin equation. First we are going to add the equation. We already have added this section what we call as an equation. So this environment, simple environment is there. Here we have to say the begin and equation. So I'm saying equation, begin equation, end equation. When you say begin equation and end equation, let's add something for here. Say f of x equals to. Now you see that I have not used that backslash and square bracket. I have also not used the dollar signs because begin and equation and equation environment won't require it. So I'm saying f of x equals to some a plus I'm saying sin, that's for the sine. Okay, sine, I'm saying theta, sine of theta, okay, plus so is theta, and then I'm saying say, and here I'm saying sine of theta and I. Okay, sine of theta I, okay, times that is multiplication, times I'm using the fraction command. Now say fraction command here, I'm saying a and some b, and just compile this. So here you will get an equation f of x equal to a sine theta of I into ab, and the equation number is added here 1. But if you do not want the equation number, you simply have to say after this no number. So if you add the no number in the equation, this command after the equation a no number, what we will see after saving and running this equation number is gone now. So by default it gives the equation number, otherwise it won't give the number. I'm simply copying this equation. Okay, this numbering system is not available in the above thing. So just like equation, you can have LHS and RHS, if you are called as an equation array. Okay, so this section we are going to use for this as a section. We can call this as an equation array, equation array. So section something is wrong, SCCDION something means we simply forgot this equation array. Okay. So you are given this equation array now, or equation array environment. We are going to create one equation using this equation array environment. So we see that is equation array, and environment is simple, begin eqn array. So when you say equation array, equation is created. Once the equation array is created, is how the standard format is how the RHS and LHS. So here having this some f of x, here f of x is the RHS side, your LHS side, RHS, then you have to have the column separator, then equal to sign, a column separator, and the RHS. So RHS side is there, so you are adding RHS side here for this equation. I'm copying this everything from the above. Okay, and say control C and equation array here, adding this control V EC. Okay, now if I want the next, you can say here nothing, simply ampersand sign equals to ampersand sign, and I'm saying some phi, okay, some pi, and then we are saying some pi of some function. consider some g of x. So we got this function. We are having this equation array. Compiling it. There is alignment type has been changed to. Okay. We have forgotten to add the new line character here, so simply have to add that new line character and you will get this normal thing. So here we got this equation. So first thing is that is equation. First line is given equation number 1, second line is given equation number 2. But if you are running this proof, many times we only require number at the last line. So you simply have to go to your source code and here simply add no number. Okay, so backslash no number. See where what happens. We say click and now for last line is not giving the number. So when you are using the equation array, you simply have to use this control X before. If you do not want to give the number to the line number 1, you have to add no number to first line. So this, you will get this equation and the equation number is given. Now if I remove the no number from this first inline mathematics, that is from the beginning equation, we remove this, and if you compile this, LaTeX will automatically make changes. This is number 1 equation, this is number 2 equation. So this is the basic information about how to typeset mathematics in LaTeX. For more, you can buy my book on typesetting LaTeX, Ready Reckoner, your project report in LaTeX, Ready Reckoner book available on Google, or you can go to the LaTeX community for things, or you can contact me. Thank you very much for subscribing my channel. To all the subscribers and those who not subscribed yet, I am requesting you kindly subscribe my channel. Thank you.